Hello everyone, we are the Invariant team, a decentralized exchange utilizing concentrated liquidity market makers, dedicated to achieving the highest capital efficiency. Originating from Solana, we've been associated with Eclipse for quite some time right now. We're excited to participate in Eclipse's first hackathon. It has been 2 weeks of hard work and we are thrilled to present the results today. CLMM or concentrated liquidity market makers, although efficient, require investors to understand complex concepts and actively manage their positions. This complexity deters many potential users before they even begin, causing them to miss out on higher profits. Moreover, improper use of CLMM can lead to significant user losses. We want to unlock the enormous potential inherent in CLMM by launching a hub that will aggregate advanced CLMM-based tools designed to minimize the difficulty for the average user, thereby exposing them to the possibility of greater profits. To understand the essence of the problem for which we build a solution, it is crucial to consider liquidity provision in the CLMM model from the perspective of the average user. We need to answer questions such as: can users determine the correlation between tokens in a pair? Do they understand the relationship between loss versus rebalancing, and can they forecast the impact of fees, impermanent loss, and rebalancing on their profits in light of price volatility? Do they have access to up-to-date data and the ability to monitor significant volume movements in real time? Are they skilled at identifying market and programming risks? It appears that these are aspects and tools that many may not fully exploit. Diverse sources suggest that a deeper dive into this subject reveals that liquidity provision can be far more profitable than initially perceived. Interestingly, the most substantial profits often emerge in unexpected places. For instance, consider a tweet from Lollipop, shared within their community, highlighting an astonishing gain of 10% in just 1 week from fees. A remarkable achievement, right? What's particularly intriguing in the specific pair involved in this profit, the FOMO to Hades pair, which maintained a relatively low concentration. This setup allowed it to manage significant price fluctuations with a fee level of 5%, a rate rarely seen in liquidity pools. Admittedly, this represents an exceptional LP position that has proven highly profitable. It serves as a compelling illustration of how sophisticated LP strategies and informed decisions can yield high returns from liquidity provision. We aim to leverage our expertise in this area to introduce a solution that could significantly propel us toward the mass adoption of CLMMs, thus dramatically enhancing efficiency in the DeFi space. We are excited to initiate this breakthrough for the first time on Eclipse. We are thrilled to introduce our new project, Invariant, which emerged from the Hackathon. This platform will revolutionize the use of concentrated liquidity market maker model, making it more accessible to everyone. Invariant integrates tools that enhance liquidity provision at various levels within the CLMM model. The first DEX to make its pools available on Invariant is Invariant, currently the only DEX on Eclipse using the concentrated liquidity model. Ultimately, Invariant aims to integrate with multiple DEXs, offering users the freedom to select the CLMM pools where they want to provide liquidity. Therefore, Invariant will aggregate pools from various DEXs. During the hackathon, we developed the Fullrange Tokenizer from scratch, which is now a key feature of our platform. Next steps include implementing the central limit order book, active liquidity management, and derivative assets. Let's delve into how liquidity provision works on the 2 largest DEXs on Solana, Orca and Radium. These platforms offer 2 main options for providing liquidity: a traditional AMM, where liquidity is spread across the entire price range, and concentrated liquidity position. This division leads to fragmented liquidity across different pools, posing a significant challenge, especially in emerging ecosystems where new tokens often have low liquidity. The lack of effective liquidity aggregation solutions like Jupiter makes this issue even worse. Consequently, this fragmentation could be a problem for the Eclipse ecosystem. The Fullrange Tokenizer offers a solution by introducing shared liquidity pools, which allow multiple applications to access the same liquidity source. This approach optimizes capital efficiency by preventing fragmentation, reducing slippage, and lowering transaction costs. Compared to separate liquidity pools used by protocols like Orca and Radium, shared liquidity pools provide a more effective way to manage liquidity. In the performance charts of both models, a notable advantage of concentrated liquidity is evident. but we can still see significant figures when it comes to AMM. And why is that? Because providing liquidity in the full range as in AMM is still necessary for many applications, and this will not change. Therefore, Invariant Link will introduce an AMM overlay on CLMM, which will allow for providing full range liquidity on CLMM. The first question we need to ask ourselves is, why use AMM a tool when CLMM has so many advantages and is so efficient? Well, AMM has several benefits that, in certain cases, made its use more justifiable than CLMM. These included auto-compounding, which allowed providers to automatically collect fees, and fungible tokens received after creating a position, which could be used in other protocols like loans as collateral, yield farming, or memcoin swaps. And why HET? Because Invariant Link introduces both of these features in its full-range tokenizer for CLMM. At this point, AMM becomes unnecessary because CLMM is superior in every aspect and on every level. To facilitate the user experience for those accustomed to using AMM, Invariant Link will introduce an AMM overlay on the top of CLMM, providing the simplicity of AMM with the efficiency of CLMM. The full-range tokenizer is a tool that enables the tokenization of position established on CLMM. The fungible tokens representing our share in a position opened over the entire range from 0 to infinity, which will be compatible with other protocols, allowing for more efficient use of our LP tokens. Another feature introduced by the tokenizer is auto-compounding. Auto-compounding will automatically compound the earned fees and reinvest them into the pools. As a result, 100% of our liquidity will always remain in the position. Additionally, the auto-compounder addresses the issue of leftover tokens, which we'll explain later. How does the full-range tokenizer work? First, the user provides the tokens they want to place in the pool. The tokenizer then increases the size of the position opened on the pool while simultaneously minting fungible LP tokens that represents our share in that position. Once the fungible LP tokens appear in our wallet, we can manage them as we wish, such as placing them in the borrow lending protocol or even listing our position for sale on the market. In the opposite direction, the user must send the fungible LP tokens representing their share of the position owned by tokenizer program, which will simultaneously burn those LP tokens and withdraw the user's original tokens from the CLMM, increased by the fees that were compounded in the position. What kind of compounding are we talking about? One of the features of the full-range tokenizer, which we mentioned earlier, is the auto-compounding of fees generated by the position. The fees are compounded every time a mint or burn occurs within a given pool. Compounding can also be triggered manually. The full-range tokenizer also addresses the problem of so-called leftover tokens, which are tokens that were not reinvested into the position during compounding due to unfavorable ratio. In such cases, a second position is opened, where these tokens are placed. The second position specifically handles any leftover unused tokens and is always denominated in one of the tokens. Based on these remnants, a single-side liquidity position is created, ranging from the current tick to the end of the possible bound, which could be 0 or infinity, depending on whether the leftovers are in token X or Y. This solution ensures the maximum possible utilization of capital. This approach is known as the zero leftovers solution. From the very beginning, we designed the Invariant Link with easy integration of multiple protocols in mind. We want projects built using our tools to be able to do so in a simple and permissionless way. Such approach allows you to stack these protocols together just as you would a Lego set. Memeswap is an example of protocol that can be built on top of Invariant Link. Such a protocol would utilize ready-made tools and infrastructure for liquidity management. Instead of creating its own pools from scratch, it could leverage those already available in Invariant Link, which would significantly reduce development time and allow the team to focus on introducing unique features, for instance like LP token lock as a solution to prevent rug pull problem, or conducting marketing. The Invariant Link also simplifies scaling as the user base grows. Unfortunately, we've reached the end of this presentation. Thanks for your attention. If you're interested in learning more about the Invariant Link project, scan the QR codes below to visit our GitHub and social media channels. That's all for today. Thank you and take care!